This is this A-level part of what the electrode potential and the cell potential. See, the question is about electrode potential in the electrochemical cell. State the meaning of the term electrochemical series, right? So electrochemical series is what is, yeah, you can also write down one also, trends in the oxidizing power of the metals, right? Or the reducing power, whatever, right? Very good. Can you go down, please? Can you go down? Thank you. The table shows some electrode potentials. See, we are getting the different electrode potential over here. Now, they're saying that state to conditions needed for the following half cell to have E dot 0.00. If I did you, can you recall, I did standard she electrode, can you recall?
Yeah.
Standard hydrogen electrode, what did I tell you? Standard conditions mean what? Tiara, can you guide me? What does standard condition mean? What does standard means?
298
Kelvin
Kelvin,
and 100
100
kilopascal.
GPa.
Now my question is
And
that can you add one more condition? Can you add?
yeah, one more.
Wait, Tiara, I'm asking, or you all
Sorry.
take a Zoom chat and add one more condition. I'll be asking the fourth condition to somebody also, right? Third condition is what? I'm changing the question. State three conditions needed. This standard hydrogen electrode is what? Yeah. 1 mole per decimeter cube. You have to take the acid solution, right? Can you tell me the fourth condition? It's very difficult. It's a A-star question. Not difficult. It's a A-star question. I didn't discuss with you. Do you know that, Snigdha? Do you know that what the fourth condition, which actually needed? The
No.
fourth condition is that you have to take monoprotic acid. Please write down that.
Oh, okay.
Why? Because you're taking a diprotic acid, right?
Yeah.
H2SO4 gives you 2H plus. Understood?
Mm.
The H plus should be what? 1 mole per decimeter cube. Understood?
Yeah.
If you take a diprotic acid, H2SO4 gives you what? 2H plus plus SO4 2 minus. 2H plus. See, 2 moles per decimeter cube we are getting.
Mhm.
Do you get my point?
Yeah.
We take a monoprotic acid. The A-star question, right? Go down, please. This is the way you do the question answers, right, Snigdha?
Okay.
Just try to go to the now. Wait. Here, see, I discussed this. Isn't it, Snigdha?
Mhm.
Isn't it, Tiara? Now everybody,
Mhm.
can you just can you just try to hide the question, hide the answer, please, quickly, Snigdha? Yeah, hold on. Please, everybody, go to that Zoom chat, please. Which is the weakest reducing agent? Wonderfully, she has done. Whenever we have got reducing agent, oxidizing agent, just convert it to simpler means. See, she has converted it. Weakest oxidized, which is weakest oxidized. Which is weakest oxidized? The species which is weakest oxidized will be what? Can you tell me? Weakest oxidized will be what? Weakest oxidized will be
The one
those
with
which will
more
be
positive.
strongest. Wait, weakest oxidized. See, oxidized.
Yeah.
Snigdha. Weakest oxidized will be what? That will be having a inclination to get reduced. Agreed? Do you
Mhm.
get my point, Snigdha? Understood? Do you get
Mhm.
my point?
Yeah.
Which is the weakest oxidized? Weakest oxidized will be behaving as what? Stronger reduced.
Reducing agent. Yeah.
No, not agent.
Oh, sorry. No. Yes.
Reduction.
Yeah.
Stronger reduction urge.
Yeah.
Understood? Urge to have stronger reduction.
Mhm.
What you to search for? Which undergoes a stronger reduction from these? Tell everybody, take the chat. And do you get my point? How to solve this question? You done just a little bit of mistake. Weakest oxidizing. Now tell me one thing, Snigdha. I
Mhm.
asked Tiara that when we go from bottom to the top,
Yeah.
the urge to get oxidized increases or reduction gets increases. First, tell me.
Oxidation increases.
Oxidation increases, as Tiara also wonderfully said. Richard, is it clear? G is equal to NFE. See, nowhere in the book is written. This trick you have to master this. As you go from bottom to the top, what happens? The urge to get oxidized increases because
Yeah.
negative delta G. Sorry, the E will be getting negative. Understood?
Yeah.
So weakest oxidized will be urge to have reduction more. Agreed?
Mhm.
Reduction. So from this species, which will be reduction most? First, tell me.
Oh, the one that's going
Having the
to.
most positive or negative? First, tell me.
If it's getting reduced, it would have
Reduce, which is the most urge to have the reduction
the
more.
positive one.
More positive. Is it
Yeah.
clear? You get
Mhm.
my point? It's a very good question. So let's clap to Snigdha. See? Understood. Right? Wonderful. Tiara, did you get this thing? Can you understand this thing, Richie?
Yeah.
Understand this part, right? How to do this? Do you get my point? Snigdha, can you just unshare the screen quickly?
Yeah.
See, I just went there fast. So I see. Anyways, I should have hold on, because it was coming into mind that shall I go a little bit slow. See, everybody try to see this. I'm again coming to this part. This part is very important. If you can master this chapter, na, 90% of the students they avoid this chapter, right? See the shortcuts. So tell me one thing. As I asked Tiara, see, going from bottom to the top, what happens? The negative number increases, right? Means the electrode potential go negative. So negative means what? Less reduction. They won't have the urge for reduction. Instead, they'll be having a urge for what? The opposite means oxidation. Bottom to the top, the oxidation urge increases. Please write down. Oxidation urge increases, right? So the reducing agent urge increases. Is it clear to you? Understand this part? If you go from top to bottom, what happens? The positive reduction potential increases. Can you see this? So one that the reduction urge increases, right? Right? So it means OA oxidizing agent urge increases. Is it clear? Do you get my point? Now, did you get my point? The strongest oxidizing agent, I can write this as what? Weakest reducing agent. Can I write this? Can I write this? Can I write this part? Suppose I'm going from bottom to the top. What happens? The oxidation urge increases. Agreed. Urge increases. Agreed. Everybody is clear. Oxidation urge increases means they will be behaving as the strongest reducing agent. No, cancel out. Now, can you tell me that this will be behaving as what? The weakest reducing agent or what? What do you think? If this is strongest reducing agent, so this bottom part will be what? Snigdha?
Weakest reducing.
Weakest. Is it clear? Is it clear to you?
Mhm.
Reducing agent? Good question. I can give you more questions to you. That will be. Is it clear? Tiara understood this part. Tiara understood? Weakest reducing agent at the bottom,
Yeah.
strongest at the top, right? Now, if I going from top to bottom, right? Top to bottom. Now you tell me. If you go to top to bottom, what happens? The positive sign increases, means the power to get reduction increases, right? Means they will be behaving as the strongest oxidizing agent. Now try to tap out everybody on the top. This will be weakest oxidizing agent or what? Did you answer this part? If this is strongest oxidizing agent, this will be weakest oxidizing agent. Is it clear? Understood this part?
Mhm.
Clear, everybody? Fine.
Mhm.
You get my point? Understood this part? Easy. Now everybody take a solve this question. That will be helping you. Means they're the father of all questions. This question. Please take a screenshot, everybody. The father of all questions. This question number 20. See, Snigdha, you went in the right path. I appreciate you.
Mhm.
You can recall the first time we did almost 3 months back. You recall that position. Strongest oxidizing agent. Guys, agent don't go through it. Don't fall in the trap of agent. Clear, everybody? Richard, is it clear? Tiara, strongest oxidizing means what? Strongest reduction. Is it clear? Is it clear? Now tell me. From all these, which will be having the strongest reduction? Will be having strongest oxidizing agent. Is it clear? Agreed. Is it clear to
Yeah.
you, Tiara? Luckily, which will be suffering strongest reduction over here? Take a Zoom chat, please.
The
Stop Zoom chat. Richard, please stop me if you don't understand, right? Strongest oxidizing agent. She recalled. I really salute your photogenic memory, right, Sigda? I'm saluting it. You recalled this trick which I taught to you earlier, 3 months back. Agent, though, go to agent. You'll be getting confused. Strongest oxidizing agent, what is it? Just do that reduction. So, which species is this? Most negative. Sorry, more positive, right? Sorry. That's right. Clear? Delta G is equal to minus LFE. So, who has that one? Tiara, who suffers most reduction? How do you do? Tiara, which equation do you use? Tiara, tell me. Tell me. G is equal to
G
minus
equals
NFE.
M minus F.
NFE.
Yeah.
So if what is this process? Tell me. What is this process? Reduction or oxidation?
Reduction.
Reduction. Is it clear to Richie?
Oh,
This is the reduction process, right? All you will be having reduction potential, right? If you do your graduation in chemistry, you'll be having oxidation potential. Just opposite. You have to flip this, nothing else. You flip this reaction, flip the sign, you get oxidation potential. You have got reduction potential, right? So which is the most spontaneous reduction? We'll be having most positive. Same thing I'm telling you. Is this helping you? Yes, it will be helping you. Most positive you have to choose. Do you get my point? Right, Richard? Right, Tiara? Did you get my point? Understand this part? Fine. Snigdha has written this answer also. My goodness. Thank you so much, Snigdha. Is it clear? Now I'm coming to the part. Strongest reducing agent is what? Most oxidized or reduced? Tiara? Richard? Everybody send me a message. Strongest reducing agent means what? Most reduced or oxidized? Please type out. Tiara? Everybody write down. Snigdha? Okay, most oxidized, right? Most oxidized, right? So most oxidized will be you have to searching what? Tell me what you have to searching. What you'll be searching?
The one
Yes, yeah, red clap for Richard. Richard, wonderful answer. Most oxidized means what is the sign you have to note? G is
negative.
equal to minus NFE. What sign you have to take? Plus zoom chat, zoom chat, zoom chat. Direct message you send. Are you will be able to search for most positive or negative? First tell me. Oxidation, right? See, these are reduction reactions given, right? Most negative or most oh wow. Richard is the fastest finger. Can you believe? Wow, brilliant. What about Tiara? Hello. Tiara,
Yeah.
most oxidized means what? Most reduced means what? What you searched? That more positive, right? Understood?
Mm-hmm.
For the oxidation, what you have to search? Which is
The
most
most negative.
negative? Isn't it? This is the
Mm-hmm.
thing you have to search. Now write down this part. Understood this part. These are reduction reactions, isn't it? So most positive will be the reduction, and the most negative will be the oxidation, right? Do you get my point, Tiara?
Yeah.
Understood? Are you getting confused? Please tell me.
No.
Suppose I'm taking this reaction. Wait. Suppose I'm taking this reaction and this reaction. Which will be suffering oxidation? First tell me.
The oxidation would be the most negative.
Negative. But prior
Yeah.
to that, what is the easiest way to do this? More positive will be suffering reduction. The
Yeah.
other reaction will be forced to undergo oxidation. Agreed? You
Mm-hmm.
have to take somebody in the cathode, somebody in the anode, right? Do you get my point, Tiara?
Yeah.
Got it?
Mm-hmm.
So most negative you have to take, right? So most negative is what? Over here, see this. Understood this part, how to handle this question. This is not in the book, I'm telling you. Now share the question, please. Snigdha.
Mm-hmm.
Seeing that today now you just send me all these, right?
Okay.
You did a see you why aren't you checking it simultaneously? I told you, na.
Oh, some of these papers I've done them like
Oh,
before,
earlier,
long
yeah.
before, earlier. So yeah,
Uh-huh. Now
and then
any
I
now
got
now
the ASP
yes.
afterwards. So then I
Thank you.
hadn't got time to mark these.
Thank
Yeah.
you so much. Thank you so much.
Should I
So
go?
very good, very good. Is it clear to you? So use a half equation in the table below to deduce the equation between reduction of VO plus 2 to form VO, right? So wait. They go up, please. VO plus 2, VO2 plus 2, VO2 plus. This is confusing, right?
Oh,
VO plus
I
2, wait
think
2.
you have to use these and then balance out.
Yeah, balance out, right? There's another equation given out. Please go up
Yeah.
for the isn't it? You have to use this equation, right? The equation from the last bottom second, right?
Yeah. Yeah.
Is the go down, please. Okay, fine, perfect, fine.
Mm-hmm.
Got it? Go down, please. Use the data from the table to explain why CO will be undergoing redox with this. Isn't it? Is it clear now? You don't have to write this. Who you have to write this? This is having more negative reduction potential, right? Is it clear?
Yeah.
Why do you write more negative? What is negative? More negative reduction potential. Tiara got understood part. We don't have to write half cooked words, right? Negative reduction potentials. That's all. More reduction potential, thus will be undergoing oxidation. Understood, Tiara? Just I understood.
Yeah.
Right, Richard? More negative. Please write down. Please write down the tricks, guys. More negative reduction potential will be suffering oxidation. More positive will be suffering more positive oxidation. Oh, reduction potential. Hello. Reduction potential. Sigda.
What? Sorry. What does reduction potential mean again?
Reduction potential is the reduction reactions which is happening. All are reduction reaction given. See, reduction potential is what? The power by which they undergo reduction.
Yeah.
Who undergoes reduction? More? Tell me. More positive or more negative?
More positive.
So what is writing? Oxidation potential that you write?
Yeah.
You write
Okay.
more. No. This is okay. This is okay. Up is okay. Up is okay.
But
Down also you have to write reduction potential. Both are reduction potentials, right? More
isn't this
positive.
one
More
negative and that
more
one's positive?
positive reduction potential will be having. Na? Are you
The
getting
FE.
confused? Are you getting confused? Unshare the screen.
Sorry, because
Please.
I was just thinking the one that's negative would have oxidation, right?
I'm coming back. Just 1 minute. It's my mistake that I was actually hurriedly doing. I'm trying to Just 1 minute. Give me a minute. Just stop, huh? Just to answer me this question, right? Just if you're getting confused like this, I'm there, right? Now my question is that now, Sneak, that you tell me,
Mm.
what are these reactions? Oxidation,
Reduction.
reduction. So these are reduction potential. Please write down reduction potential, right? All are reduction potential. Now come,
Yeah.
this is done.
Yeah.
Now if I'm taking zinc and Ni,
Yeah.
what we have to search for cathode? Positive reduction potential or negative reduction potential? We have to use this formula, G is equal to minus NFE.
Mhm.
For this reaction, what's the reaction? Reduction reaction.
Yeah.
So which is more positive reduction potential to take for the cathode or negative? What do you think?
So you take the positive one.
More
So
positive, so right, more
yeah.
positive reduction potential. Understood? Now
Oh,
oppose now
okay.
now by default what happens? By default what happens? The more negative is this.
Yeah.
This will be becoming oxidation. This will be going to the oxidation half
Yeah.
cell.
Yeah.
So what you can write in the opposite way? More negative reduction potential undergoes oxidation.
Oh, okay.
Are you getting confused, Tiara?
No, not really.
Right? Is it clear, Richard? You can play around the words like this.
Yeah.
More positive will be the more positive will be more negative G, spontaneous process. Negative positive is negative. For the other part, that has to be meekly accepting going to the anode, right? Clear? Understood? This is already taken the seat of the cathode. So can zinc come to the cathode? No, no. It has to be in the anode. And what's the thing? This is more negative. So more negative reduction will be going to the anode. Is it clear or oxidation? Clear?
Yeah.
Now share the screen. Thank you so much, guys. Just share the screen. Snigdha, you just marking and send this to me, right?
Mhm.
Good. That go down, please. Go down. Suggest why two cobalt complexes in the table have a different electrode potential, right? Can you go up, please? Good question. See, everybody now do topic wise papers. Have you completed this actually, Tiara? Tiara, have you completed this? And Richard, please complete this after the physics exam, right? Two cobalt has got different what? What were they saying? Different
And something. Sorry, let me just
different actually electrode potential,
electrode
right?
potentials. Yeah.
Electrode potential, because why? Because they're having different ligands connected to it, right? The
Yeah.
ligands, right? They're having
Yeah.
different ligands connected to it, right? So
Hmm.
they're making it. Now go down, please. See, you won't be getting the answers in one go, right? Please go over this, right?
Mm.
Wonderful this. So this table below suggests this reaction. Letha explain why aqueous electrolyte is not used in the lithium cell. Okay, aqueous electrolyte is not used. The equations are this is from lithium cell, right? That lithium cell, right? Go over the lithium cell also, right?
Yeah.
Titiara, can you send me a message, please? 20.3, most important. Electrochemical cells, most important, right? Electrochemical cells, most important to study first, right? This answer is given in your that book, right? And
Um.
write down electrochemical cell and types of electrochemical cells, right? This, huh?
Yeah.
Okay, the equations are less negative, right, than lithium over here. This hence they are reduced and produces charged ions which can react with this. Very good, right? Why we cannot use, right? Is not used, right?
Hmm.
Go down, please. This is a good question. This is a very tricky question. This is easy, right? To find out the EMF, right?
Mm.
A standard lithium iodine cell, right? Can you go up, please? What is the iodine? Lithium iodine. So if
Um.
take the most bottom reaction, see, guys, can you see this? Iodine and lithium reacting. Which reaction to choose from? First reaction and the last reaction. More positive will be the cathode, more negative will be the anode. Anode, you have to do what? You have to flip the reaction, right? Flip
Yeah.
the sign and add up. After that, you add up. Sneak, are you subtracting at straight away? You can also do this also. E right
Uh,
minus E left. That also you can do.
oh yeah.
Or
Yeah.
you can flip it and add it also. Got it?
Oh, okay. Yeah. I
Go
think
down,
I
please.
use this equation
Yeah.
instead.
No worries, no worries. Go down. Okay. The EMF value of commercial lithium value is this. Suggest why this value is different from the value calculated from this. And standard condition. Wonderful. Can you see the this equation? This is not considered a standard condition. We don't do in a standard condition, right?
Mhm.
Can
Yeah.
you tell me that for non-standard condition, what's the equation called? Can you guide me, Stigda? You don't have this in your exam.
Uh,
Nernst equation, right? You can write down Nernst equation.
oh,
Use the Nernst equation to find out the E cell value for non-standard condition reaction. Right? You can write down. Question might
this
pop
one.
up. Yeah, this you can calculate using Nernst equation.
Sorry, how do you spell that?
Nernst. Nernst equation. Nernst equation.
That.
Nernst equation. Yes, perfect. Nernst equation. Nernst equation is the equation to find out the E cell under non-standard condition, right? Means you need the E dot cell value also to calculate after put it, right? Fine, guys. Anyways, can you see the questions? The questions is something different. That's a very important part of A levels, right? The questions is has to be gone through, right? Fine. So, anyways, Snigdha, Tiara, just to complete these portions and just send me a message, please. In the next session, I'll be carrying on the question papers of electrolytic cell also, right? This EC cells,
Mhm.
right? Fine, guys.
Could you
Ye-
also do chromatography, please?
Oh, chromatography, right? 1 minute, 1 minute. Uh, you know what, Richard? If you have a physics exam, no, you can leave now, or I will be sending the